Bismillah. Hello, this is Nas Babar from NB Network Solutions. Today I am going to be presenting IP address. We're going to go ahead and bisect IP address. We're going to look at decimal form. We're going to look at binary form and so forth. In my last lecture, we went over binary numbers. Hopefully you have a good grasp on binary numbers. And then we'll go ahead and get started with the IP address, but I just kind of want to give you a quick recall from binary. 128, 64, 32, 16, 8, 4, 2, 1. This is basically the reference number. So please keep that in mind because it's going to help you do mental exercise and convert decimal to binary and binary to decimal in your head once you get used to of this. So if you can write down this reference range on piece of paper and then practice yourself for the conversions, that would be helpful. I'm going to help you with the look at the IP address now. So IP address, as I mentioned before, it's a 32-bit long binary number and divided into 4 octets. For example, this 192.168.100.20 is divided into 4 octets. Octet 1, octet 2, octet 3, octet 4, and so forth. In every decimal, in every octet, there is a decimal number, and you have to convert that decimal number into binary form. It could be zeros, ones, and so forth. So that's what we're going to look. So as far as IP address, if you look at RFC 1938 and IEEE, you will see that IP address has 5 classes. Class A, Class B, Class C, Class D, Class E. We're going to focus on Class A, B, and C. D is used for multicast, which is beyond the scope of this lecture, and E is used in experimental world. So let's go ahead and get started. So in Class A, the first octet decimal range is always going to be 0. Okay. Class B, 128. So Class A has the last decimal 127. 128 through 191. The next one starts with 192 to 223, and then D, which is used for multi-class, 224 to 239, and the next one is 240, and the last one is going to be 255. So how I got this one is basically, if you think about it, let me just do this, make it a little simple for you. This might help you understand it quicker. So Class B starts with 128. So Class C has to start with 128 plus 64, 192. Class D has to start with 224, 128 plus 64 plus 32, 224. Class E, 128, 64, 32, 60. So you got 240, starts with 240. So hopefully this, and if you look in here, Class B starts with 128. So Class A has to end with 127. Class C starts with 192. So Class B has to end with 191. Class D starts with 224. So Class C has to end with 223. Makes sense, right? Class E starts with 240. So Class D has to end with 239. So guess what? Class E would end with 255, 255, 255, all ones. So let's look at the first octet in binary range. So in this particular case, if you look at the binary range, it's all zeros. First one is going to be zeros. All of them can be anything. It could be ones, it could be zeros, and so forth. Why? Because the thing is that the first IP address starts with 127. Now, if you have this bit 1, there's no way that you're going to start with 127. So that's why this bit is always off. Look at the Class B. Class B ranges from 128 to 191. So the first bit always stays on, okay? And also the second bit stays always 0 and the rest can be anything. Why? For the same reason, if you add 120, if this bit is on, 128, 64 is 192, there's no way you're gonna get a range of between 128 and 191. So that's why first two bits are always going to be 1 and 0 in a class B. Class C starts with 192. Now in order to get 192, this has to be always 1, okay? 128 plus 64, 192. And this has to be always 0 and the rest of them can be anything for the same reasons which I just explained. Because if you make this bit 1, then you're going to have a number more than 192, which is not acceptable. So class D, 224, basically in this particular case, you have first 4 bits, first 3 bits always going to be 1, fourth one is always going to be 0. Class E, first 4 bits are always going to be 1. Why? For the reasons, if you make 128, 64, and this is going to be 1, and this is going to be 1, so this makes it 128 plus 64, 192, 224, 240, all right? And rest can be anything. You cannot make this 0 because then you will never get 240. So that's the logic behind that. Now let's go ahead and move on to the IP range. So IP range is, if you understand this part, you're already ahead in the game, trust me. So IP range right here, it's going to be basically in this case for this 0.0.0.0 starts with 0, and then you go to 127. This is the first IP in the range. This is going to be the last IP in the range. 255, 255, and 255. Okay, so first IP 0, the last IP is going to be 127 something something something. In this particular case, when we have 255, basically what I'm seeing is that this is all ones, this is all ones, this is all ones. So class B, let's start with class B. Class B, we're going to have 128.0.0.0, and it's going to go up to 191. How about instead of 255, I just use F, okay? When you get into the networking world, you'll see a lot of time, when I used to work for Cisco TAC, we used to always say F, 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 which is 255, 255, 255. So if I say 191.f.f.f, that's basically 191.255, 255, 255, just a short, I have to complete the video within 15 minutes. So in this one, class C, you have 192.0.0.0, and the last network will be 223.f.f.f. And then there is, we're not going to basically discuss class D and class E because that's class D is multicast. We'll get to it when I prepare a network lesson for multicast. So now we're going to talk about the default subnet mask, which is going to go in this column right here. The default subnet mask for class A is 255.0.0.0. For class B, it's going to be 255.255.0.0. All right. And then class C, we have 255, 255, 255, 255, 255.0. Okay. So now the fun part comes. We need to calculate Hello, this is Nas Bauer again. This is the IP address part 2. Part 1 is also posted. This is part 2. Like I said, I have to basically compress my video or make sure that video stays within 14 or 15 minutes. Otherwise, I can't upload it. So I apologize that I have to do the continuation, but IP address part 2 begins now. Last time when we stopped, we were basically going over the number of hosts and number of networks, how to calculate those. And let me just recap a little bit real quick. So basically we said number of hosts is going to be how many zeros you have, okay, within your subnet mask. So this is basically what I've done is that class A subnet mask is basically 255 0.0.0. 255.0.0.0. Number of zeros, 8 3s are 24. Formula 2 to the raised power n minus 2, whereas n being number of hosts. So in this case, in class A, 2 to 24 minus 2 will give you number of hosts. Why do I have minus 2? Because you have a network IP which you cannot use, and then you have a broadcast IP which you cannot use. Same thing, let's move on to class B. Class B, I have 16 ones, and this is on default subnet mask, which is 255.255.0.0. So I have 16 ones and 16 zeros. So 2 raised to power 16 minus 2 will give you the number of hosts. Let's move on to class C. So in class C, the default subnet mask is 255.255.255.0. All ones for this 255, all ones for this 255, all ones for this 255, and zeros for this. So this part is only left for the number of hosts. So 2 to the raised to power, in this case, is going to be 2 to the raised to power 8 minus 2. That will give you the number of hosts. Now let's talk about number of networks. So that's a little bit tricky, but I am sure that you can grasp it. So in this particular case, in case of the number of networks, you have to look at the number of ones, okay? So in this case, you have number of ones, how many? 8, okay? First one we cannot use because that's going to be always 0. So that's going to be basically 2 raised to the power 7. Let me repeat. In class A, you have 8 ones in the first octet, rest is zeros. We cannot use those. We can only use those for the number of hosts. 8 ones. So you would think in your mind, why can't I use 2 raised to the power 8? But you can't. The reason for that is because first bit is always going to be 0 in class A. So that's the reason you cannot use it. 2 to the 7 is going to give you the number of networks. Moving on to class B. If you look at the class B, you have 16 ones and 16 zeros. And we said number of hosts, it's going to be 2 to the raised to power 16 minus 2. How many number of networks are we going to have in this? Think about it for 1 second. Look at this right here and tell me. 1 and 0, the first 2 bits are fixed. We cannot use them, okay? Because earlier in my lesson 1, part 1, I explained you that 1 and 0 is because if we have 1 over here, 128, we cannot have a number more than 128. If I use this 1 also and 1 also, that's going to make it more than 192, which is not allowed. So these 2 bits are always going to be 1 and 0. So we have to do for number of networks, 2 raised to the power 14. Okay? Class C. Class C, what we do is that what we see is that we have 192/23. If you look in here, first 3 bits right here. Let me use the red marker so you can see these right here are always going to be same. Okay? So then what does that mean? That means right here in class C, I have how many ones? I have 8, 8, 8, 3 8s are 24. However, I cannot use the first 3. So 24 minus 3 is 21. So it's going to be 2 raised to the power 21. And then if you want to look at the class D, you can do that also. Do it yourself. And then send me the answer and see, I'll check it out. But this is all I have for lesson 2. In the next IP address, lesson number 3, what I'm going to do is I'm going to go ahead and look at some examples. We're going to have some IP addresses, and we're going to try to go out of the traditional subnet masking, which is called CIDR. In other words, you can basically move the default mask, even though it's a class A or class B or class C. We can change the subnet mask. That CIDR, that's a little bit progression. We will talk about that. We will put some IP addresses. We will put the mask on there, and then we'll ask you do it in your head and see how many number of hosts, how many number of networks, or at least how many number of hosts you have in this. So we'll do that, and hopefully you'll gain some knowledge on that. But that is all I have for today. Thank you so much for watching. Please do provide feedback. If I missed anything or if I made an error, please do point it out in order for me to progress myself. And if there is a mistake I made, please correct me. Thank you so much.